Okay, for number 78, we're supposed to solve these, and we'll set up an algebraic equation and then solve the algebraic equation. The width of a rectangle is 6 kilometers less than twice its length. If its area is 56 square kilometers, find the dimensions of the rectangle. Okay, first let's look at, I was going to say the rectangle, and they've given us the area. Basically what we're going to be doing here is using the formula for the area of a rectangle, and that is area equals length times width. Okay, and well, we'll get to that in a moment. So our rectangle, let's take a look at it. There we go. And let me see. The width is described in terms of the length. So you use the same variable for length and width. Each one we'll say is an x. Okay. And the width, it's supposed to be the shorter side, so that's where I'm going to put it. Alright, so let me see, the width of a rectangle is 6 less than twice the length. So here's 6 less than twice the length. Okay? And we have our form, and let me see, it's the area is 56 square kilometers. So what we end up with for area, we have 56, okay? And then we're supposed to have length times width, so it's x times 2x minus 6. And we're going to solve for x. If this was equal to 0, that'd be fine, but it's not. So I'm going to have to subtract 56 from each side. In order to combine it, I've got to get rid of the parentheses. So you send in your x, you get 2x squared minus 6x. So I've gotten rid of the parentheses. And now you want it equal to 0, so you can use the zero factor property. So get rid of 56. So you have 0 equals 2x squared minus 6x minus 56. And you want to use zero factor property, so you're going to try to factor. And remember, whenever we're factoring, we can refer to this little road map. Is there a GCF? Yes. So let's get a 2 out of each term. So I'm going to factor a 2 from each term here. And I'll still have equals 0. Be sliding this up soon. So this would leave me with x squared minus 3x minus 28. I'm going to list all the factors of 28 and look for a difference of negative 3. Just slide this over now. So for my 28, 1 and 28, 2 and 14, 3 won't work, 4 and 7. So if I have negative 7, positive 4, that'll do it. So this can be factored as x plus 4, x minus 7. This 2 drops down, and it's all equal to 0. So I have something times something. Well, something times something times something equals 0. So you set each factor equal to 0. The first one, 2 is equal to 0, is kind of ridiculous, but I'll just write it and then discard it. Okay? Because I just want to emphasize you take each factor and set it equal to 0. So I'll say, better come back up here. 2 equals 0. You toss it because that's not true. Then you try x plus 4 equals 0 and x minus 7 equals 0, and get rid of your 4. You get x equals negative 4, and get rid of your negative 7. You'll say plus 7 and plus 7. You'll get x equals 7. And now notice that when we made these variables, we're talking about length here. If I plug in a negative 4 here, it won't make any sense because you can't have a negative distance. And even if I plug it in here, I would get a negative 8 and a negative 6. So x equals negative 4 simply can't work. You can't have a negative length. So x is 7, and that means you take this 7 and you plug it in wherever there's an x. All right? So here you would just get a length of 7. Here you would get a width of 14 minus 6 is 8, and these are kilometers, so I'll just put K for kilometers. And again, it's a little backwards because the width is supposed to be the shortest side. Alright, so that's 78. We'll take a look at 81. Alright, we have an object thrown upward from the top of a 160-foot building with an initial velocity of 48 feet per second. I could draw a diagram and everything, but they actually give me the equation. And h, where do they say that? The height h, okay, height, h is the height of the object after t seconds, that's our time, t is time, is given by this equation. When will the object hit the ground? Well, we haven't solved anything with two variables, and you're going to have to pick up on something. H, that's the height. When the object hits the ground, what is the height of the object? Well, it would be 0. All right? Height is h. When the object hits the ground, the height will be 0. All right? So you can put in a 0 for the h and solve for t. You'll find out the time. So that's negative 16 t squared plus 48 t plus 160. And now when you're factoring, you want the rules for factoring. GCF, yes, and we'll proceed from there. So in fact, I don't like a negative in the first term. You might realize that you can factor a negative 4 out of each term, and I'm actually hoping for something bigger. Notice 16, I could factor it out of there, 10 times 16. So, and 16 goes into 48, all right? I think this problem, even if you don't factor out the GCF, you might be okay, but it definitely messes up the box method if you haven't factored out the GCF. And to be in good form for factoring, oftentimes you'll get the wrong answer if you don't. So I'm going to factor out a negative 16 from each term. And that's going to leave t squared minus 3t minus 10. All right, and this is all equal to 0. Then you proceed down the list. 2 terms, no. 3 terms, yes. Anything in front of the first term, no. Well, there's a 1. Okay, so you just grab the last term. You grab the 10. List all the factors. This won't take long. 1 and 10, 2 and 5. We're looking for a difference of -3, -5, +2. So we have the factored form. That's going to be t plus 2, t minus 5. And we also have a -16 sitting out here. So you would grab each factor and set it equal to 0. -16 is not equal to 0, so I'll just toss that value. But I'll take t plus 2 and set that equal to 0. I'll take t minus 5 and set that equal to 0, and then solve for t. So subtract 2 from each side. Add 5 to each side. And t is time, okay? They want to know, when will the object hit the ground? Well, it can't happen in negative time. So you toss that answer and you keep this one. When will the object hit the ground? It will be 5 seconds. Okay, so that's 81. We'll take a look at 84. The number of sides n for a polygon that has 35 diagonals. And the main thing is they've given us the formula up here, okay? So this tells us, let me see, d equals all this, gives the number of diagonals d. So d is the number of diagonals, okay? So they tell us on number 84 here that it has 35 diagonals. So we'll plug in, we'll use this formula, but instead of big D, we'll put a 35, okay? That's how many diagonals? 35. And then the rest of our formula. 1/2 n minus 3. And we're trying to use the zero factor property. I don't really have another way to solve this. So I'm going to send in the 1/2 n to each term. That'll give me 1/2 n squared minus 3/2 n equals 35. And we want this equal to 0, especially because we have the n squared, okay? I'll have to slide this up some. I have some guinea hens out there a little bit upset about the math. Alright, so we'll subtract 35 from each side. Again, because we want this equal to 0 when you have an exponent of 2. We don't really have a way to solve it without factoring. So to use the zero factor property, I need all this equal to 0. So, well, we have our 0. And on this side, we have 1/2 n squared minus 3/2 n and minus 35. Okay. It's still solvable dealing with these fractions, but it's just going to look complicated. So we learned early on how to clear the equation of fractions. I think we'll do that now, okay? Again, it's solvable using the fractions, but it just looks rather complicated as we do it. All right. So to clear it of fractions, you look for the LCD, which is a 2. So you're going to multiply each term by a 2. And hope you remember how these cancel. Nothing reduces here, so 2 times 0 is 0. It's like I'm running off my paper here. 2 goes into 2 once, 2 goes into 2 once. 1 times 1 is 1. So you just have n squared. 2 goes into 2 once, 2 goes into 2 once. 1 times 3 is negative 3n. And nothing, I can't reduce because there's no denominator. So it's just 2 times 35. There's negative 70. Okay? So we're trying to solve for n. There's nothing in front of n squared, so I just grab the 70. And list all the factors. 1 and 70, 2 and 35, 3 won't work, 4 won't work, 5 goes in there 14 times, 6 won't work, but 7 times 10, and hey, there's our difference of 3. So it must be negative 10, positive 7. So the factored form is n plus 7 and n minus 10. You have something times something is 0, so we'll say n plus 7 equals 0, and we'll also say n minus 10 equals 0. You're going to solve for n, subtract 7 from each side, n equals negative 7. And add 10 to each side. So you get n equals 10. Or rather, okay, so n equals 10, and we said there were 35 diagonals. So if I have a 10-sided figure, n is the number of sides. Okay, so if I have 35 diagonals, it must be a 10-sided figure. Okay.